So we've loaded in the data, and my first step will be to clean it up and explore it. Data exploration is one of the most important parts of the ML workflow because it allows you to notice any initial patterns in data distribution and features that may inform how you proceed with modeling and clustering the data. So above, I loaded in the CSV file as a county's data frame, and here I'm just printing out the number of rows and columns in that data frame. Then on that data frame, I'm calling .drop NA across axis equals 0, which means I'm dropping any rows that have any incomplete data. And I'm saving this cleaned data frame as clean counties DF, and then I'm printing out the shape to see how many rows of data I've lost. So if I run this cell, I can see that I originally started with 3,220 data points and 37 columns. Then after this cleaning step, I can see that I've dropped 2 rows of data, and now I'm down to 3,218 data points. Okay, so this clean data is what I'll want to use as I continue to process this data below. Next, I wanted to create a new data frame, indexed by state county instead of individual indices. So for each of the data points in our clean counties data frame, there is a state and a county value, and I can merge the two into a single string using a dash character. And then to index our data frame by this value, I'm going to call cleancountiesdf.index and set it to a new state-county value. So this is the first step, and I can see that now instead of having individual indices here, I'm indexing all the data by its unique state county. But I haven't dropped any columns yet. I can see that the state county corresponds to the index, and so now these 2 columns are actually redundant, and I can get rid of them. I'll also get rid of the census ID column, which doesn't really give me any meaningful information about these counties. So that's exactly what I'm doing in this next cell. I'm specifying the names of each of the columns that I want to drop, and then I'm calling .drop on our clean counties data frame to create a new clean counties DF. If I display a few of these points, now I have the data frame that I want, indexed by state county and with numerical features as columns. And I can see that I've actually gone from having 37 column values to 34, and I can print out the entire list of those feature values here. So here's a list of all those column names in our clean counties DF. We have the total population, counts of men and women, racial counts, labor counts, and a bunch of other data here. And now that we've completed this step, creating a nice clean counties data frame, we'll be able to do some interesting visualizations, looking at the distribution of data over all of our counties. In fact, in this next step, I'll want to compare some features and learn more about them. In the next cell, I'm going to display some histograms of our features, which will show the distribution of data points over discrete feature ranges. So first, I'm making a list of features that I want to compare. In this case, I've chosen a bunch of transportation types. These are specifically recorded as commute types. Do people drive, carpool, take transit, walk, or use another method when they commute to work? From looking at my data frame, I know that all of these features are represented as percentages, and so the x-axes of these plots should be comparable. So for each feature in this transport list, I'm going to create a single histogram, grabbing the feature values in the clean counties data frame by name, and specifying a number of bins to make in our histogram. So here's one example histogram of people who mainly drive to work. Each of these bin widths describes some sort of feature range. In this case, percentage points, so from about 0 to 5, 5 to 10, and so on ranges of percentage points. Then the y-axis is how many data points actually fall into these bins, so how many counties fall into a certain feature range. There's some spread here, so really I can see across counties, people commonly drive about 70 to 85% of the time, and there's even really small bumps close to 0% of the time. If I scroll down, I can see the same data for people who carpool in each county. Looks about like 10% of the time for the majority of counties. And I can see that for public transit and walking. And just intuitively, I think this makes sense. I think the concentration of people who use public transit are probably in big cities where those systems are already built, and it makes sense that that's a small percentage of the population. Now I want to note that I haven't sorted anything into clusters yet. I'm just looking at how people in our counties classify their own transportation method to work. I can even change the number of bins if I want a more granular look, upping the number to get a more detailed description of this distribution. Now this is only an example for transportation data, and there's a lot of other features in our data set. So as an optional exercise, I'm challenging you to create a set of histograms of your own. Create a list of features that you're interested in looking at, and display the resulting plots. After that, you'll be asked to normalize this data in preparation for training a PCA model.